Hello and welcome back to another devlog on the things I've been up to. Over the summer, I looked into a variety of features to prep for my senior computer science capstone project. But since school is back on now, I'm feeling good to start talking about the premise of the game. I'm wanting to create a creature collection / fighting magical life sim. After doing a lot of design writing, a few big systems have come to mind. An inventory system for the player to manage their resources, a dialogue system to interact with NPCs and objects, an animation system to drive creatures and characters, a save and load system, a date and time manager, and a vegetation system to handle the massive amount of foliage that I want. If I were to build this system strictly on the CPU side, the frame rate would be awful. So I'll need to leverage the GPU for this. Unlike the compute shaders I made for fractals and bending, this system has way more moving parts to it. We've got our mono behavior, which will be coordinating everything, such as which meshes to use and how much grass to render, and most important of all, where to actually put it. I've seen other examples directly sampling a mesh, but for a future goal I've split this into a separate mono behavior, a point cloud source. In this case, the source will be a mesh, so it'll be similar to other examples you would see on YouTube. Now that we've got our points, we need to ship it to our compute shader as a buffer. You can think of a buffer as a special list. This shader will turn our buffer of vector 3 positions into a buffer of transformation matrices for position, rotation, and scale. After that, the matrices come back to our manager, and we push all of that info to a special graphics function. This function will trigger some lower level code, which will be more efficient. This also takes in our mesh and a special material shader. We can't use a regular material shader. We need one that can work with our transformation buffer. And with that, grass is rendered. Well, should be. The fact that everything is compiling is a good sign to diagnose the issue. Turns out my biggest issue was misspelling the insertion function's string, and that was causing a majority of the glitchiness. This entire ordeal reminds me of my low-level C class, where we had the safety for memory access turned off. You see those little pink squares outside the game view where icons usually are? That's my system corrupting video memory. It sounds really bad, but closing and reopening Unity fixes this. Honestly, I'm surprised Unity never crashed from this. If it did, I honestly would have just shelved the entire system and tried something else. After fixing all the errors, we've got grass. Now, when I see other people's grass videos on YouTube, they're sourcing their points from meshes for the sake of a tutorial. Now, this has downsides, as anytime you want to create grass on a surface, you'll either need Pro Builder or another 3D software to model out the mesh where grass is supposed to be. Instead, I made a spline-based solution where I can draw out a region. Even though Unity provides their own spline package, I decided to roll my own so I can get B-splines. Instead of fine-grained control that you see with like Bezier curves, B-splines are blobbier by default, which works nicely for grass patches. Each point in the spline region gets raycasted downwards onto surfaces marked as walkable. This amount of raycast sounds expensive, which it kinda is, but I can 1. Split a spline point into multiple grass points, and 2. I only need to do the cast on 1 laggy frame. Perfect for a loading screen. For now though, I'll keep the mesh approach until I build out a better demo level. If you look outside at natural grass, you're not gonna just see the same grass over and over. You'll see patches of other types of plants, which is why I built in support for multiple mesh types through weighted randomness. After all the work I've done, this system still has its bugs, such as floating meshes, but I've got other things to work on, such as freelance work, which I can't really show, and school. I've got 4, kind of 5 courses this semester. One of them is music and film. It's one of my free random picks for my degree, and hopefully I'll be able to describe sound on a more technical level than I do right now, which is not that much at all. I've got a computer science course on automata theory. This includes topics like finite state machines and regular expressions. On the math side, I've got my analysis course, and I am so glad I prepped for that over the summer. We've already had our first homework assignment, and oh man, is it a lot. Funny enough, on the day it was due, my professor apologized for it being too much. I've really enjoyed his classes, and I owe a lot to his linear algebra courses, but fingers crossed that the next homework assignment is lighter. Now I said kind of 5 courses because I'm kind of doing a TA job for multivariable calculus. Rather than me teaching class and grading work, I get to sit down on class. I also get to make doodles during class, and I hold regular study sessions outside of class with worksheets I make. Lastly, and most important of all for the Devlog series, I've got my first semester of my computer science capstone course. I've been going back and forth on something. I think pitching a game for my capstone is a bad idea. While building a minimum viable product is great to have, my schedule is way too packed to have it be review ready by early December. Another part of the capstone is writing up a technical report on the project in the second semester, and in the second semester, a lot happens, and I don't think I'll be able to completely work on the game until I finally graduate. To get around this, I got an idea. I want to focus on a single system for the project. A game featuring lots of 3D creatures is going to require a lot of animation work. Rather than making all the animations by hand, I want to use procedural animation instead. On the spectrum of game animation, we have your traditional animation where the artist has complete and utter control over the final work, but as we go to the other end, more of the work is driven through code and algorithms. This includes stuff like IK foot placement, where a character's feet snaps to the ground. Now, I don't want to go full-on procedural animation, but I want to be close. There's the GDC talk from a handful of years back on an indie game called Overgrowth. In that talk, the developer interpolates between character poses to respond to the character's state. This is what I'm hoping to achieve for my game, and I feel that it's super doable for me. In fact, I was already experimenting with the architecture when I was building out the character controller. However, I'm going to have to rework everything from scratch, as finite state machines would likely be better to build on. I've never implemented those patterns before, but it shouldn't be too bad. Plus, I mentioned earlier that my CS theory course is going to cover this topic, which is a huge plus for me. But enough talking about planning, I want to make some art, specifically a bush. To me, nature modeling is a balancing act of managing chaos. You don't want to have so much chaos that the form is messy, but you need enough chaos for it to not look artificial or hand-placed. So this is a perfect chance to use geometry nodes in Blender, as it's pretty much modeling with code. After some tinkering, I've got a bush, and here it is in Unity with the down-res look. I also gave it some physics by having the bush point towards an invisible collider that the player interacts with. As a nice side effect from this, I can increase the mass of the sphere's rigid body to slow down character movement. And I'm not just interested in 3D art at the moment, I'm also interested in doing 2D concepting. Compared to 3D modeling, I've doodled way less over the years. I don't consider myself a good drawer, but I feel like I'm good enough that I can get an idea down that I can reference for later. I think it's fair to say that most people don't enjoy bugs, so one hurdle will be how to convey friendliness. An easy solution is thicker and stubbier appendages. I feel like what most people don't like about bugs aesthetically is their thinner and lengthier body parts. Hopefully I can get around this, but I'll need some research, especially if I want to go the opposite direction for enemies. To wrap things up for this devlog, I wanted to create an outline effect for when I have interactable items. There's an easy technique for modeling outlines that involves inflating a mesh, inverting its normals, and assigning an unlit material. But that doesn't really work for some types of meshes. That includes my bush, because some of the meshes are just single-sided triangles. Instead, I chose to make a custom render pass. This turned out to be way more difficult than I thought due to how much Unity's rendering system has changed over the years. Sometimes I would find resources online, but they would just be deprecated. But after overcoming that, I've got outlines by only changing a GameObject's layer. During the rendering sequence, it creates a separate image mask, with only renderers with that special layer. We only need a binary mask, so let's just toss out all the other shading. We then run this through a dilation shader that checks the neighboring points of each pixel. If a pixel touches a white pixel, it gets switched to white. To get an outline, we need to subtract our original mask from our dilated mask. Last of all, we composition our mask back onto the frame being rendered. After working on this feature, I realized I am so tired of working on render programming, and I don't know why I just keep circling back into render programming. Although it's really satisfying to have the final result, they are a nightmare to debug. If you've ever done multi-threaded debugging, this is kind of like that, except you don't get print statements, and you're working with thousands of mini computers running all at the same time. For the rest of September, I'd like to work more on mechanic features with plain old C#. And I'm hoping that by saying this in a video, I won't circle back around to render programming for some reason. I've got some big ideas for this game, and I hope to document them through these videos. Thank you for watching. If you enjoyed this video, please consider subscribing. Have a nice day, and I'll see you in the next one.